Okay, in this given question, the table shows the information about the heights of the 80 children. So first, we have to find out the interval containing the median. So as we know, the number of children is 80. So the interval containing the median will have 40 and 41st child. So if we add these three values, it ends with 39. So it clearly shows that the 40th and the 41st child will be in this interval. So the answer is 1.65 less than h less than or equal to 1.8. Now the second question, we had to estimate the mean height. So first of all, we will find out the mid values of the heights. So mid values, I call this as h. See, to find the mid value for the first interval, we add upper and the lower bounds 1.2 plus 1.4 by 2. We take the average of both. So which is 2.6 by 2, 1.3. So 1.3. I'll follow the same procedure for rest of the intervals. We get the mid values as 1.3, 1.45, 1.575, 1.725, 1.85. Now the given corresponding frequencies are, I call it as F. So as 2, 13, 24, 32 and 9. Now we will find total height, which is HF. So if we multiply 1.3 and 2, we get the answer as 2.6. The same thing, same procedure we follow for the rest of the values as well. We get 18.85, 37.8, 55.2 and finally 16.65. If we do the sum of all this, 131.1 and sum of the frequencies is 80. We know that already. Now, estimated mean will be sum of FH or HF by sum of F, which is 131.1 by 80. I use a calculator to calculate this. I get the answer as 1.63875. So this is the estimated mean. To the B question. So here we had to find out the one of these children is chosen at random. So we had to find the probability that they have a height of 1.4 meters or less. So now first of all, let us find number of children with height 1.4 meters or less. So number of children with 1.4 meter or less is 2, because this is a category. So now probability of children less than or equal to 1.4 is 2 by 80. So if I simplify this fraction, I get it as 1 by 40. Now in the second question, we had to choose 2 children at random. Okay, and the given condition is both the children are taller than 1.5 meter, but only one of them is taller than 1.8 meter. So number of children taller than 1.5 meter but less than 1.8 is, it comes under this category. So number of children taller than 1.5 but less than 1.8 is 24 plus 32, which is 56. So one child has to be definitely taller than 1.8. So number of children taller than 1.8 is 9. So this is the only case, taller than 1.8, which is 9. Now we have to find the probability under given condition. So the probability will be 56 by 80 multiplied by, for the second child should be chosen from this category. So it is 9 by 79 because one child already chosen. So number of children will reduce to 79. Likewise, two children has to be chosen. Therefore, we multiply it with 2. Now we simplify this calculation part. We will get it as 63 by 395 as the answer. So here we are supposed to find out the cumulative frequency of the table. Okay, we use a original table to find this. Okay, the cumulative frequency was nothing but adding the first and the second likewise. Okay, so now 2 plus 13 gives us 15. By adding this 2, we get 15 as the answer. Now this both if I add, I get 39. This both if I add, I get 71, and this both I add, I get 80. So now I fill these values here, which is 15, 39, 71 and 80. Now I am going to use these values to draw the cumulative frequency diagram. First of all, I had to check for 1.4, which is 2. 1.4 is here, the 2 is here. I'll mark here. Now for 1.5 it is 15. So under 1.5 I'll go for 15. This is 10, 12, 14 and 15 will be in the middle. 1.65 it is 39. 1.65 is 1, 2, 3, 4, 5. This point I should mark 39. So 30 is here. So 30, 32, 34, 36, 38, 39 will be marked here. So at 1.8 it is 71. So this is 1.8. So this is 70. And 71. Okay. .70. .71. At 1.9 it is very simple, 80. So now I'll join all this point together to form a frequency curve, cumulative frequency curve. Right. Now these are the points. Okay. Now let us find out the interquartile range. Now we know interquartile range is nothing but upper quartile minus the lower quartile, and lower quartile is at 1 by 4 n plus 1th value on the cumulative frequency axis. So which is 1 by 4 of n is 80, 80 plus 1, if I simplify I get 20.25. So now upper quartile is 3 by 4 of n plus 1th value, which is 3 by 4 of 80 plus 1, which is 60.75. First of all, let us find the upper quartile. So now for this, I will draw a horizontal line from these points. So first I consider the 60.75. So I consider it as 60 and draw a horizontal line at the point 60. And this horizontal line I'll make to meet it at the curve and drop a vertical line from this to meet the x-axis. Yes, what is this value? 71, 72, 73, 74. I'll make it clear. (71, 72, 73, 74, 75). So upper quartile I got it as 1.75. Now coming for this lower quartile, I will draw it at the point 20. I draw a horizontal line and make the line to meet the curve at this point and drop a horizontal. So it is 1.52. If I subtract this 2, I get 0.23 as my interquartile range. Therefore, the value of interquartile range is 0.23. Now, we have to find out the 60th percentile. 60th percentile is nothing but 60 by 100 of n plus 1th value in the x-axis. So here n is 80. So which is 60 by 100 of 80 plus 1 will be 48.6. Let me consider horizontal line. I'll allow to meet the curve and drop a vertical line from there to meet the x-axis. So here quartile range as 0.23. Use a rulers to find these values.